So here's the review for the final exam, and I mean, just for the sake of those who are not here, I just thought I should record it. So that's the first question, and you've already read it. So you have 2 point charges. One is 22 microcoulomb, the other is 35, and they are kept 0.4 meters apart. Okay. Question is, at what point along the line joining them is the electric field 0? So assume that the electric field is 0 here, r distance away from the 22, so this distance should be 0.4 minus r. I've already told you that, just for the sake of this, I'm repeating, okay? And then whenever you talk about electric field, imagine that there is a 1 coulomb kept at that point, okay? So you now imagine, it should be 1 coulomb, not 1 microcoulomb. Imagine there is 1 coulomb kept there. Okay, I just need to correct that. Kind of, yeah. So 1 coulomb kept there, and find the force by each one on that 1 coulomb. If the field is to be 0, then the two forces must be equal and opposite, correct? Because everything being positive, this is going to repel this way, and this one is also going to repel it the opposite way. So the forces need to be equal. And that's the formula for force. So I'm going to set up 2. I am not even changing micro into coulombs. There's no need, because both sides will be in micro, right? So it will cancel out. So on the left side, k times 22 times 1 divided by r squared. And on the right side, k times 35 times 1 divided by 0.4 minus r squared. Now this is where I said, got to be careful. Cancel the k's out, take the square root. So on this side you'll have square root of 22, and here you'll have square root of 35, and the squares would get cancelled, right? Okay, I don't think I've written everything, so, or maybe I have, I don't know. Okay. And then cross multiply and solve it. I think I've taken the square root and solved that. Yeah, 4.69 is the square root of 22. And 5.91 is the square root of 35. Okay, and then I've cross multiplied it. And distribute this, you got to distribute this, right? Don't you have to? Well, or you can do it other ways, you can divide, or do it how you like. And then 1.22r, and I think I made a mistake there, and then I changed it. It's 10.6r. Because then when this goes to the other side, it becomes positive, see? So add these two, you get 10.6r is equal to this, 0.17. This is how I did the B part, as I explained. Now the midpoint is going to be 0.20 meter, right? Half of 0.4. And I said that the two forces are going to act opposite to each other. So I'm going to take the bigger force. Isn't that the bigger force? The 35 microcoulomb creates the bigger force, minus the smaller force. So I'm using the formula K Q1 Q2 by R squared. But where is Q2? Why is Q2 missing? Because it's 1. Correct. Because it's 1. And you notice that in both cases the distance is 0.2. Now what I did is just got a little smart. Took out K, took out 10 to the negative 6 because it's all common. You see that? 0.2 whole squared. I just put all the common factors outside, and then I'll be left with 35 minus 22. That's a smart way to do it. Does that make sense? Does it? Yes. To simplify the calculation. So I took all the common factors out. I'm left with 35 minus 22. And then I put the value of K, which is 9 times 10 to the 9. And then 0.2 squared is 0.04. 35 minus 22 is 13. That's all. So you do that calculation, you get 2925 times 10 to the 3. Which is 2.925 times 10 to the 6 Newton per coulomb. So that's how you do that. Those who are not here, in this question, these two are connected. How are these two connected? Yeah, so just be careful. For the formula for capacitors and resistors are just the opposite of each other. That's why some students get confused. For capacitors, when they are parallel, you just add them up. So 10 and 2.5 become 12.5 microfarad. And then that 12.5 is in series with 0.3, which is where you have to use 1 over C is equal to 1 over C1 plus 1 over C2. So that's what I've done. So the 10 and the 2.5 are parallel. So add them up. You get 12.5 microfarad. And then that 12.5 is in series with 0.3. So use the formula and find that. 1 by 12.5 plus 1 by 0.3. Essentially, if you only have two, I've told you it's product divided by sum. Didn't I tell you that? Like product divided by the sum. So multiply them, divide by the sum of them. And you get 0.293 microfarad. So you know that when a conductor is heated, its resistance changes, right? Agreed? Normally increases. For conductors, the resistance will increase. So for the copper wire at 0.5 and the iron wire, both are going to have an increase in temperature. But if I give you the alphas, you will notice that the alpha of iron, for those who are listening, is more than the alpha of copper. So which one is having a greater change in resistance? I just said it. Greater alpha, iron. And iron already has a higher resistance. You see that? So if you heat it, I'm just trying to use the concept. If you heat it, there is no way copper can catch up with iron, is what I'm trying to say. It's like having two runners. Keep the faster runner up in front and the slower runner behind. Copper is the slower runner. Iron is the faster runner. Do you ask them to run? Do you ever think they'll catch up? This guy can? No. But if you ask them to run backwards from there, there is a chance of them catching up. You know what I'm trying to say? I mean, it's not a perfect example, but you know what I'm trying to say. So if they are asked to run backwards, which in this case would be cooling, instead of heating, you cool it, and this is going to have a bigger drop, see? Because backwards or forward, this guy can run faster. So it's going to be like, cut up. So that's the point. So at what temperature are their resistance is going to become equal? Now I'm talking about concepts. Do you see that? When you do problems, you actually have to talk about concepts. Now, the formula for this is RT is R0 times 1 plus alpha delta T, where RO is the resistance at 20 degrees Celsius. Alpha is the constant that I've been talking about. It's called the temperature coefficient of resistance. Okay? So that's RT is equal to RO times 1 plus alpha delta T. Alpha is the constant.
We don't use a T minus 20? Or that's the change in T, right?
Yeah, it's a change in T. You're asked to find the temperature. So just put change in temperature. Okay? You will see it when I solve it. You're not going to make a mistake if you put T minus 20 there. Don't worry. All right, so set that up for both. So I'm going to say ROC, that C is copper there. Just writing the equation for both and putting them equal to each other. That's all I'm doing. So on the left-hand side, you have copper, right? And on the right side, you're going to have iron. So R naught of iron times 1 plus alpha of iron times delta T. The rest of it is just math.
Don't we need alpha?
You need alpha. I'm going to give you alpha. It'll be given to you. Okay, so you have to distribute, rearrange. That's the algebra part, which is what I'm doing now. Did anybody get why I've got this? Because this times 1 and then this times 1. See? So, and I brought this to the left side, so it became negative. And then I'm going to have what? This times this whole thing, right? Minus this times this whole thing. Okay, that's the math part. I just took out delta T common because I knew delta T is going to be there in both. So I took it out common. And here are the values of alphas. Fine. 0.00651. The unit is per degree Celsius. I didn't write it there. So did you notice that the alpha of iron is bigger than that of copper? It's very funny, you know. One time there was a mistake when I gave this problem. I don't know how it happened, but I had it the other way around. It's like the one that started behind. See, this way they can catch up, right? That way, when I had given it, it was mixed up. There was no way they could become equal. Oh, the students spent so many minutes trying to solve it. You don't get an answer. One student said they can never become equal. Got full credit on the exam. Everybody else is like, the conceptual part that I said first, they never thought about that. They were like, put it into math. Try. Oh, it won't work out. You can't get it. Like if I had switched the alphas of iron and copper, you know what I'm saying? So you have to be careful. When you read the problem, think about what you're doing and try to solve it. Okay. Where did I get that 0.025 from? That's the difference, right? 0.525 minus 0.5. I have it backwards. That's why it's negative. According to the formula. Well, there's a lot of calculation in this. That's why you have calculators. So the right hand side, the whole thing becomes 0.00148. And then you have to divide. The answer is going to be negative, isn't it? Yeah. That's when you get negative 17 degrees Celsius. I got negative 16.89.
Where did you get negative 0.025?
Difference?
ROC minus ROF.
ROC minus ROFE. ROC is 0.5. RO of FE is 0.525. The difference. Is that? Got it? What would be the application of this? I mean, thinking about concept. What would be the application of if a conductor is heated, its resistance is going to change? How would you use that?
When it's heated?
Either way, I mean, what could we build using this? But it's not so easy for you to answer. We build a thermometer using this idea. Because you can measure the temperature. What's the advantage of that temperature? It's called usually the material used is platinum. It's called a platinum resistance thermometer. The advantage, you can use that to measure very high temperatures. Can you use a mercury thermometer for very high temperatures? Well, you can only use it up to the boiling point of mercury. After that, you won't see anything. You know what I'm trying to say? But with a conductor like platinum, which has a very high melting point, it won't even melt. So platinum resistance thermometers are used to measure very high temperatures, working on this principle. That's how it connects to you, college physics. That's why I just mentioned it. Okay, great. Okay, in this question, we only got the change in temperature, so we got to find the temperature, which would be 20 minus 16.89, which would be approximately 3.1 degrees Celsius, right? That would be the answer. Just reminding you, and please watch, we're talking about the top mesh here, right? This one. So if you decide to go clockwise, starting from A, are you not going in the direction of the current? Therefore, you take it as? I don't know, you could go either way. So I told you negative. All right, so it will be minus I2 times R2. Come on. Minus I2 times R2. Agreed? And then here, then it should be plus 18. Then minus I2 times R1, small r1. And then you still go, that's easy because all the currents are in the direction we're moving. So all products are going to be negative, isn't it? Minus I1 times R1 is equal to 0. That's all. That's all. You don't need to solve. You just need to know how to apply. Now, when you see this, don't shout me down. But let you see the whole thing and then decide whether it's okay to write the way I wrote it. Because the rule can be either way. You know, I just want you to stick with what I told you, but it can be either way. Did you notice that it's going to be the same thing? Because I reversed everything, correct? I think some of you, are you confused? On the first one, we said this would be negative, this would be positive, these two would be negative. Didn't we say that? Which is the same thing.
You would do that if you're going opposite of the current?
No, I mean, you can do it. It's the rule because each textbook is a little different. So I had forgotten what I told you, but it's the same because I can't even give an example now. Yeah, I think I can. 15 minus 10 minus 5 is equal to 0, isn't it? But minus 15 plus 10 plus 5 is also 0, is what I'm saying. Because if you put something equal to 0, then, and if you change the sign of everything, it's still going to work. All right, everybody got that? Yeah.
So whenever you're going across
A resistance,
a battery, or the 18 volts,
you look at what you're going towards. So in this case, you're going from the negative to the positive, correct? So I think I told you, think about what you're doing when you go through the inside of the battery. You're going towards the positive, so take it as positive. All right, so we should not spend more time on that. Now that's what the equation is. I just put the numbers. And then I saw that I2, there are two terms with I2, so just combined it. Just to make it look cool, you know. So 6I1 plus 3I2, because this is 2.5. So that's the equation in the perfect sense. So. And yes, remember the formula. And so always I go with the fundamental. You know, when anything goes in a circular path, the centripetal force should be equal to the magnetic force, correct? So that's what I've written. Centripetal force is equal to the magnetic force, maximum magnetic force. So from there, I get the formula. The One of the velocities on the left side crosses out and you get the radius. We've used this several times, mv by qb. And you're asked to find b, so rearrange and substitute the numbers, you should get the answer. Mass of the proton is 1.67 times 10 to the negative 27. Here, the velocity with which it is moving is given. 7.55 times 10 to the 7. Then the charge. Charge of the proton is the same as the charge of the electron. And then the radius. Such an easy, direct question. Yes.
Would this be on the exam? Like for sure?
You mean the same words and the same? No.
Different numbers.
None of these problems like that are going to be there. You know what I'm trying to say. But you got the idea? Then you can do a problem related to that. I am trying to cut out memorizing because memorizing in physics is useless. That's why. Like you do 10 problems and you get the 11th one, which is the same as the 10 before. Anybody can do that. So B is 1.036, which is what I got. Okay. The peak EMF is NBA omega, but they do not know what that stands for. All right, let's try. What's N?
N's the number of turns.
In the coil. B is the magnetic field strength. A is the area of the coil. If it's circular, it will be pi r squared. If it's rectangular, it will be length times width. See, and omega is? Omega is not rotations per minute, it's radians per second. So once you get omega, you should know how to get the frequency. Omega is 2 pi times the frequency. All right, so let's go. Save time on that.
So to go from radians to RPMs, you do 2 pi.
You have to divide what you get by 2 pi. F is omega by 2 pi. So first I'm going to find omega there. Peak is 465. The number of turns. And please read the questions carefully. You see what's given is not the radius. Did you notice? That's in centimeter too. So B into, I just got lazy. I put pi there. Pi r squared. But did I take half of the diameter? And did I change it into meter? I did. 8 divided by 2 is 4. And then I changed it into meter. That's why you have the 10 to the negative 2. Okay? So I got 704.75 radians per second. And omega is 2 pi times F. Now why so? Because in each rotation, the angle is 2 pi radians, isn't it? So if it makes 10 rotations, it's going to be 10 times 2 pi in a second. So there you have a problem again. That's going to be per second. Watch. That's per that's per second. What do I do to change it in a minute?
Divide by 60. Or multiply by 60.
Which one? Multiply. Because it's so many rotations in a second. And you're looking for how many in a minute. Definitely it's going to be multiplied by 60. Didn't I do that? Oh, I didn't. Okay. I forgot. So, to change that, now we'll have to go, that's 112.15 times, let me keep it like this, 60, how much does that come to? 6,730. Okay. Rotations per minute. So you go from rotations per second to rotations per minute. C is F lambda. use that formula to get the wavelength. And all electromagnetic waves have the same speed, which is 3 times 10 to the 8 meter per second. So divided by the frequency given, which is 60 hertz in this case. And you get the wavelength to be really big. It's 0.05 times 10 to the 8 or 5 times 10 to the 6. Yeah. Maximum magnetic field. Does anybody remember the formula? C is E naught by B naught. C is E naught by B naught. So rearrange and find B naught. E naught is given in kilovolt, so that's why it's 28 times 10 to the 3. Change the kilo. Then you get 9.33 times 10 to the negative 5 Tesla. Okay, in that question, the focal length is positive because it's a convex lens. So F is given. What is it? 11.5. DO. Because the mole is the object, right? And you're asked to find DI. Find where the image is. Simple enough. So DO is given. F is positive. 16.5, and you should get DI. Cannot afford to make mistakes on questions that you already know, okay? Be careful on the exam. Just calculate very carefully. One by DO plus 1 by DI is 1 by F. Put it into that. Rearrange. Make 1 by DI the subject. That's 1 by 16.5 minus 1 by 11.5. See, I'm moving this slower than usual, have you noticed? So you get more time to. You get a negative 0.0263, but remember that's 1 by DI. So DI will be the reciprocal of that, which is negative 38 centimeter. Which is 0.38 meter, negative 0.38. Magnification, what's the formula? Negative DI by DO. Always remember the negative. But when you use HI by HO, there is no negative. So M is HI by HO. So directly you get 3.3. I didn't even bother to write those numbers. Right. 38 divided by 11.5, isn't it? And the negatives cancel out, that's why you get a positive number. That's why you know it's a virtual image. And then use M is equal to HI by HO to find the height of the image. Magnification is negative 40, and I've already explained this, but I have to repeat. So magnification is minus DI by DO, so put that number that you've given, negative 40 is negative DI by DO. Let's at least speed it up. Okay. So DI is 40 times DO, and then 1 by DO plus 1 by DI is 1 by F. In place of DI, put 40 DO. and then solve it as you like. Multiply top and bottom with 40, right? On the first one. Is that okay? Because then you will be able to add the numerator. You get 41 by 40 DO is 1 by 0.5, and then solve for DO. What is that? The pen slipped there. Anyway, let's see. Yeah. Okay. So that's DO. Now, how do you do the second part? Don't say. You first find DI, which you did, or which we did, 40 times 0.5125, which gives you 20.5 centimeter. Magnification is given as what? 4 times? So, like I told you before, DI is negative 4 DO, right? Because negative 4 is DI by DO. And then put it into that. 1 by F, so F in this case is 5, right? Okay. You're looking for DO. You find DO. Wait till the end, otherwise you'll be confused. You're like, what is he doing now? DO is, can't remember, 3.75 centimeter. What's DO? That's the distance of how much the object should be in front of the eyepiece, isn't it? So you're getting that. You got that now. Okay. Then, because you're asked to find the distance, see what I did. How did I get 24.25? 24.25? How did I don't know. I got it.
You added it to 20.
20.5 plus 3.75. That's what I was trying to say when I showed you this. Look, this. See, that's what I was trying to say. Add. But before you add, you have to find the DO of that to add it. Now that is a very good question. If I ask a question like that, wouldn't it take like 15 minutes?
Yeah.
And then you have to save time on the other problems. All right, we did not do the diffraction grading thing, but I think most of you got it. That's why
Yeah.
you have to find D first and then. That's all. Essentially, once you get sine theta, you just, if your calculator is in the degree mode, you get it. But for me, it happened to be in the radian mode, so yeah.
See you guys tomorrow.
.09552, so I had to change that into degrees. Don't worry about that. It's simple, to change it, multiply by 180, divide by pi. So you get 5.48 degrees. Again, if your calculator is in degrees, you will get it straight directly in degrees. So